Section 12.7a is about adding rational expressions again, except this time we're not going to have common denominators. So we're going to have to work to get them, and to do that, we need to learn about this idea of least common multiple. A lot of people confuse least common multiple with greatest common factor, so I'm going to try to show you the difference right now. The least common multiple is the least number that's a common multiple of two or more numbers. Now it also works with monomials and polynomials, but let's start with numbers right now. So if I have the number 6 and 20, and I want to find the GCF, which is something we've done in the past, you're going to take and make a factor tree of each one. So 2 times 3 is the factor tree of 6, and 2 times 2 times 5 is the factor tree of 20. Now the greatest common factor says take every factor that's in common. In this case there's a 2 in common and that's it. So we would say the GCF of 6 and 20 is 2. Now I show that to you because that's what we've done in the past. You have to be careful not to do that when you're finding the least common multiple. Now I already have the factor tree breakdown over here, so I'm going to write the prime factorization of 6 and the prime factorization of 20. Now the key when you're looking for the least common multiple is you're going to take every factor the maximum number of times that they appear. So that's a key to finding the least common multiple. Notice it doesn't say take the max times it appears anywhere, the max times it appears in any factorization. Well, let's see what that means. I have a 2, and it doesn't have to be in common. I just have a 2 factor, so I'm going to take a 2 out. But the question is how many 2's? Well, you take the factor of 2 the maximum number of times it appears in any factorization. Well, here it appears once, here it appears twice. So I'm going to take 2 2's because it appears twice in the second factorization. Now I see another factor of 3. It doesn't matter if the 3 is in common. I'm still going to take the maximum of 3's. Well, I see 1 here and none here. And then I'm going to take the 5. And now I'm going to multiply all that together, and I'm going to get a least common multiple of 60. So notice the difference. Greatest common factor is a number that goes into 6 and 20. Least common multiple is the least number that 6 and 20 would create if you multiply them by other values to get a 60. So 60 is the smallest multiple of 6 and 20. Here we're asked to find the least common multiple of 2 monomials. We'll start by creating the prime factorizations. Now if you don't need to do the factor trees, that's fine, you don't have to, but you do need the prime factorizations, and you take every factor the maximum number of times that it appears. So here I see 1, 2, I see a 3 on top and 2 3's on the bottom, so I take the maximum number, I take 2 of them. I see a 5, I see an M on the bottom and 2 M's on the top, so I'll take 2 of them. Remember, we want to take the maximum number of times, but not a combination. Top there's 3 B's, bottom there's 2 B's, so I'll take 3 of them. So here 9, 3 times 3 is 9, 9 times 5 is 45, and 45 times 2 is 90. I have an M squared and a B cubed. So the least common multiple of these 2 monomials is 90M squared B cubed. Here we want the least common multiple of 2 polynomials. Well, if these were monomials, we'd do a factor tree, and that's how we would factor them. Here we have trinomials, and the question is, how do we factor trinomials? The answer is with a diamond. So I need 2 factors of 15 that add to be 8. So this is going to be an x plus 5 and an x plus 3. So that's what this trinomial factors, and then this one factors to be x plus 3 and x minus 2. 2 factors of negative 6 that add to be 1. Now, to find the least common multiple, you do exactly the same as you would with numbers or monomials. You take every factor the maximum number of times that it appears. So I see an x plus 5. That's one of my factors. I see an x plus 3. There's 1 in the top and 1 in the bottom, so I only take 1. And then I see an x minus 2. So my least common multiple includes each one of these binomial factors. Okay, so the whole purpose of learning how to do least common multiple is so we can use that idea to find the least common denominator of a fraction. So if you look at these two fractions, I need to find a denominator that's common between them. So I want to find the least common denominator of a and 3a. So I'm going to go over here and do that. The least common denominator, because these already have factors. The factor here is an a, and the factor here is a 3a. We're going to take every factor the maximum number of times that it appears. I see a 3, and I see 1a on the left and 1a on the right, so I'm going to take 1a. So it turns out that my least common denominator is 3a. Now, what does that information do for me? Well, here's what it does. I'm going to rewrite my entire problem out, and I'm going to create 3a's on the bottom. Well, this one's done. I already have a 3a. But what can I multiply this fraction by to give me the 3a that I want? The answer is 3 over 3. So I'm going to simplify now. This 3 has to be distributed. So this would be a 3a plus 3 over 3a. And this one, a minus 3 over 3a. So that's how I create the common denominator that I'm looking for. Now this becomes just like a problem in section 12.6. You're going to combine the tops together over the common denominator of 3a. And now we'll collect like terms. 3a and a is 4a. 3 minus 3 is nothing. Over 3a, the a's can cancel, simplifying to leave me 4/3. Here we have an example where we need common denominators, but we have polynomials. Best thing to do is to break those into binomial factors by factoring. So I'm going to use the diamond here. Two factors of 4 that add to be 4 are 2 and 2. So I'm going to cross that out. So it looks to me like my denominators are y plus 2 on the right and y plus 2 on the left. So what is my least common denominator? Remember to take every factor the maximum number of times that it appears. On the right you have 1y plus 2, and on the left you have 2 of them. So if we're going to take the maximum, we're going to take 2 of them, because there's 2 on the left side. Remember, it's not a combination. We're not going to take 3 of them. We're going to take the maximum number of times that it appears in any denominator. So rewriting, the left side is just going to stay the same because it has the denominator that we want. And we're going to have to do something to the right side to get this denominator. So what can we multiply y plus 2 by to get y plus 2, y plus 2? Well, the answer is another y plus 2. So we'll do that. And then we'll simplify y minus 2 over the denominator that we want. Now over here, y minus 2, y plus 2, those are conjugates. They create a difference of squares. You square the first term, you square the last term, and you put a minus sign in the middle. And that's over the y plus 2 times y plus 2 denominator that I was looking for. So now that these have common denominators, it's a matter of adding the tops together and putting them over the common denominator of y plus 2, y plus 2. Now I'm going to put this in descending order with the y squared first. Then I'm going to put the plus y. Then I'm going to take negative 2 minus 4 and make it a negative 6. Now it looks to me like the last thing I should do is take that trinomial on the top and factor it. Two factors of negative 6 that add to be 1, y plus 3, and y minus 2. And that's going to be over my denominator of y plus 2, y plus 2. Now it looks like you might have some canceling here, but actually there's nothing that cancels because you have to do the entire group. So this would be a final answer, and if you want to write this bottom as y plus 2 with the squared, you can.